There is nothing as dense as a flat earther. Relatively speaking, of course. Gravity can't work with a flat earth. If you're anywhere near the edges, you'll be walking around at an angle. And of course, the first thing a pancake roll would do is collapse into a ball under its own weight. That is why Anthony Riley and the other fum ducks came up with Relative Density Disequilibrium. A great group of people who aren't dense at all are my amazing patrons. To all my patrons, including new patrons Jason Blackford, Colin Field, Scott Emmett O'Donnell, Irish Dublin, Bob Yake and Kiri Mack, and my latest patron, Brainery. Thank you all so very much. So Anthony Words Matter Riley and Nathan Purple Toy Oakley, let's conduct an experiment to check out this relative density disequilibrium. Roll VT. So just for Riley and Oakley, let's test out this relative density disequilibrium crap. If we take an ordinary object, say, I don't know, a grape, and then we let go of it, it will drop, as expected. Well, according to Oakley, Riley and other gatherers of guff, the reason the grape went in that direction is that it is denser than the air that surrounds it. And so everything sorts itself out according to its relative density. The grape is denser than the air, so it moves downwards until it hits the table, which is denser than the grape, and it stops. But what is density? Density is nothing more than mass divided by volume. How much stuff there is in a given space. It is not a vector. There is no direction. So why does it move at all? For an object to move, there must be a force that acts upon it. Well, we know that you don't believe in gravity, so what is it? Perhaps we should try to remove any external influences on the grape. We can run the same test and use a jar. The jar is still open to the atmosphere at the top, but nothing can affect the grape from the side. Let's drop it again and see what happens. Well, we seem to get the same result. The grape, which is denser than the atmosphere, still moves downwards until in this case it's stopped by the bottom of the jar, which is denser than the grape. Now there are no influences coming from either side, although one question that pops to mind is if it sorted down to the dense glass at the bottom, why didn't it divert to the dense glass at the side? But the jar is open at the top. Perhaps this is having an effect. Let's isolate the system of our test. The grape is now sealed off from the entire planetary system. There is no such thing as gravity. The grape doesn't know that there's a table there. The grape doesn't know that there's a whole planetary body below it, and the grape is not being affected by the atmosphere. So let's run our test again and see what happens. Oh dear. So why did that happen then, you clowns? Yes, we have the density of the grape. Yes, we have the density of the air within the jar. Yes, we have the density of the jar and the lid itself. You need to explain why these relative densities decided to sort themselves out in the order that they did. Perhaps there's something special about the lid. Let's run the test yet again. Well, now we have a conundrum. One time it sorts air, grape, lid. The next time it sorts air, grape, glass. Why did it decide to do it one way one time and the other way the second time? Well, either the lid and the glass must have exactly the same density, or their densities change, and I can't imagine that happening. And if the lid and the glass do have exactly the same density, how did it decide to head in one direction and not the other? Let's try it again. Same result. Why don't we try it on its side so that the lid's not getting involved? Well, straight away we got a puzzle. We have the grape surrounded by air, glass above and glass below, and yet it sits at the bottom. Let's try tilting the glass jar and see what happens. Now how would relative density disequilibrium explain this? As you guys love claiming, you can't have gas pressure without a container. Here we have a container, so the gas within inside, the air, is at 14.7 pounds per square inch throughout. So why does the grape suddenly decide to rush from one end to the other when the container is, apart from the lid, the same density throughout, the air is at the same density throughout, and the grape's density doesn't change? Well, that's all very interesting, and relative density disequilibrium cannot explain it. Let's try something further and take gravity out of the equation. Let's look at an experiment where gravity is removed. We've got two ping pong balls floating on water. Here we have a density tower. We've got the heavy, dense liquid at the bottom, the ping pong balls, which are less dense, floating on top, and the air above them. This is on a plane that flies parabolas. It's colloquially known as the vomit comet. As it flies over that parabola, you become weightless. Let's see what happens to the balls. As everything on the plane becomes weightless, there is no longer any up or down. The water, air and balls can no longer sort themselves out into any order. The only difference is it's zero gravity. There is no force pulling them down and creating that density tower of liquid, ball, then air. What? You don't think that's a proper density tower? Let's try again then. Here's another guy using a more recognisable density tower. At the bottom there's a coolant. Then there's blue dyed water with vegetable oil on top and air above that. Despite his small bodily movements, the tower remains intact with everything in order. Then he enters microgravity. He tries to hold the jar as still as possible, but any movement is enough to send those three liquids mixing thoroughly. They're no longer stacked in order of density. No longer is there an obvious clear layer at the bottom, then blue layer, then oily layer with air above. It's all one homogeneous mix. You can even see bubbles halfway down the tower. Each parabolic curve of the flight giving 0g only lasts 20 to 25 seconds, and as it comes out of the parabolic flight you can see instantly the tower is starting to reorder itself. At no time during that entire flight did any of the elements in that density tower change density. The only thing that changed was gravity. It became weightless. Relative density disequilibrium is a busted flush. It explains nothing. There is no reason for any direction just based on density. We're not talking and arguing about too difficult to understand scenarios like string theory versus loop quantum gravity. We're just talking gravity. Mass attracts mass. Things drop down towards the earth because it's a very, very large mass. I wonder if I used a TDS meter and put salt in the jar, would that have made my grape float? The whole thing with flat earth is stupid. There is no evidence for it. But relative density disequilibrium is an idea for snakeheads. Until next time, stay sensible.
Shut up and sit down.